Welcome to the channel of Professor Davinci. Radius perpendicular to the tangent. So first I explain what is a tangent. Suppose we have a circle. Tangent means it is a line passing through the circumference touching at a point is called a tangent. Suppose if we have any circle, the line passing through this, so here the line is not touching the circumference, so the line is not a tangent. So tangent means a line have to pass through the circle touching at least a point, at most a point, not at least, at most a point. So here the tangent, the line, suppose for example this is a AB. AB is a tangent, so I can say that AB is a tangent to the circle, this is a C. Okay, so this is a tangent. Here what is happening, it touches the circumference, I mean it touches the circle at the point T. Assume that we have any point, say this is the tangent. Okay, let us take, no need to mention the name of the line. So assume that this is the point touching the circumference is the T, and somewhere, some point I take some point as a I put in a different color. So this is a T and this is the A, and this might be the center O. Okay, now I just draw a line. I'm just drawing the line touching the point A and B. Okay, right. Now a tangent is a straight line just touches the curve at a single point. That is the definition of the tangent, right? Now here the tangent is here. Now it is not a AB, is a tangent, so I can say this a tangent is a tangent is a straight line that just touches a curve at a single point. Here the single point is T. Here it touches the single point T, right? Now consider the tangent TA, where T is the point of contact to the circle. Obviously T is the point of contact to the circle, and A is any point on the tangent. Okay, so A is any point on the tangent. Now it is clearly mentioned that you may also observe that the theorem often states that a tangent will be, a tangent will always be perpendicular to the radius of the point of contact. So what is the theorem stated? Theorem states that a tangent will always be perpendicular to the radius at the point of contact. Okay, this is the theorem. Theorem states that if we draw a line from the radius to the point, the tangent, the point which touches the line, touches the circle, the line always, the radius will always perpendicular. This is 90 degree, always perpendicular. This is the theorem, right? So keep in mind, a tangent will always perpendicular to the radius at the point of contact. If suppose if you are given with the line, okay, if you are given the center point, say this is center point O of the circle, and any point on the circumference, it is possible to derive the equation of the tangent of O's. Okay. So once we know the center point, we can derive the gradient of this. We can derive the radius of the, gradient of this radius. By the gradient of the radius, we can find the equation of this tangent. We can find the equation of the tangents, as we have seen in how we have formulated the equation on the chord last video. Okay. So in this case, once we find the gradient, we obviously can find the gradient of the other line perpendicular. Suppose if m is the gradient of any line, and if a line is perpendicular to this m, then the gradient of the perpendicular line will be minus 1 by m. Already we have seen. For example, I tell clearly, suppose if OT is the radius, okay, OT is the radius, and assume that say mr, okay, mr is the gradient of OT, okay, right? Now if we need to find the gradient of TA, so TA is the tangent, and as per the theorem, it always perpendicular to the radius. So if a line is perpendicular to any line, so say perpendicular to radius or any radius, then the gradient, so now we can find we can say the gradient of the tangent, we can say the gradient of tangent is mt will always satisfy the equation minus 1 by mr. Okay. Once we find the gradient of the tangent, we can easily formulate the equation of the tangent. What is the equation of a tangent or equation of a straight line? Y minus y1 equals m into x minus x1. Here what is the m here? mt, right? So this is the theory behind that perpendicular, radius perpendicular to the tangent, or tangent perpendicular to the radius. So this is how we formulate the equation of the tangent. Okay, understand? See you guys, have a great day.